Hello everyone. So today we start our new section on strings. Um, so this is going to be relatively simple compared to our previous sections, previous topics, and the topics coming up after this one. Um, okay, so let's get started. Uh, jump ahead. So far we have treated strings like um, other primitive data types in Java. Uh, in this section, we take a closer look at strings, and we learn that the string variables that we've been using so far, they're actually not a primitive data type. Behind it is actually the string class of the Java API, which means actually so far uh, the way we have been creating strings wasn't we can actually we can do it that way, of course, s- but we can also do it in a way that is more familiar to us from our study of classes and of creating objects from classes. So let me give you an example over here. All right. So say we have. So this is pretty familiar to us. So we can create a string just like this. We've been doing that for a while now. But this is not how you would usually create an object of a class. Um, you would do that with something. I'll show you how. So we usually use the new keyword for that. And if string is a class, we have to call a constructor like this one. And in this case, uh, for the string constructor, we can pass the string that we want to keep, the text that we want to keep in that string object. So you can see that, check this out, both of these actually work. Um, let's print these out and show you that whether we create a string one way or the other, we don't end up with a compiler error of any kind. Out, print line, and then we print out string S2. And you can see that string S1 is created one way, string S2 was created using the new keyword, the method that we would expect to use if we treated string uh, as a string as a class. You can see that when you run these, both work equally well. String 1, S1, contains the text hello, comma, world. String S2 contains the text hello again, world. And you can see they both work equally well. So this, the way we create string S1, the way we've been creating and initializing strings up to this point, is basically just shorthand for the method used to create the second string, S2. Um, so which means I could also I could also use the default constructor, the no-arg constructor, for the string uh, class, and that will also work. Obviously, I'm not providing any argument for this string when I'm calling this string constructor. And you can see that string S3 turns out to be an empty string, null string. Okay. Now, before I move on, there's one other thing. Yeah, so there are lots of operations that you can perform on strings, uh, and we'll be looking at a good number of those in today's lecture. And here's the thing: you already know what an immutable class is. An immutable class is one whose data members, data member variables cannot be modified, cannot be changed after the object has been created. Something very important to remember is that strings are immutable, meaning that once you create a string, you cannot modify it. Okay, that sounds new. Um, it throws up the question, what happens if I were to try to run code like these two lines that I have over here? So what we're doing over here is we're creating and initializing a string object S with the string, with the text Java. And in the second line, it seems like I'm assigning a new string, HTML, to that same string, S. Now, it looks like we are actually changing the contents of the string object S. But, like I just told you, string class is immutable. Contents cannot be changed. So why is it that when we run these two lines of code, we end up not having an error of any kind? Let's try this out very quickly. So we have string S3. Um, let me do something over here. So string, uh, let's do kind of same thing that's going on over there. So I already have string object S3, and in the following line, I'm going to assign to S3, let's just use a shorthand version, hello yet again world. Okay, so I guess if strings are immutable, then once I create a string object S3 with a null string, I should not be able to assign a new text, a new string to that string class, the string object. Let's see if that is the case. Let me run this. Let me look here. When I print out S1, S2, and when I print out S3, it says hello yet again world. This string, this text that I assigned to a string S3. So it does look like I, that I can change the contents of a string object after all. But how does that make sense? Let's go back over here and let me just explain this very quickly. There's not much to it though. So, the first line does exactly what we think it does. It creates a new string object and initializes it with the text Java over here. But when the second line executes, what happens is the existing string object is not modified. Instead, S is just a reference to a string object. A new string object is created called HTML, and S starts pointing to that new string object. And because the reference to the first string containing Java is then lost, or basically we have nothing pointing at it anymore, Java will remove it during its regular garbage collection process. So this first string object ends up being deleted from memory. So this is what's actually happening over here, and this is why, although strings are immutable, uh, when you're coding, um, it does seem kind of as if we are able to modify existing strings. But that's actually not the case. Anytime you assign a new string, a new text to a string reference, you're actually deleting a string object and creating a new string object. So that's what's actually happening. Okay, so that's a distinction you should be aware of. Okay, so let me add another string over here. Call this one string s4. Create a new one, new string. Hello world. There you go. Okay. What we can also do is we can compare strings to each other to check if have the same contents. Done easily enough. Um, so, as an example, compare strings S1 and S2, and when you compare stuff, uh, when you compare two strings, they can either be equal or they may not be equal, true or false. So if I want to compare string S1 with S2, this is how you would do it. S1 equal to S2 equal to is of course the comparison operator. It's not an assignment. Okay. And let me also compare string S1 with string S3 and also with string S4. Okay. And let's print these out. So let's take a look. String S1, hello world. S2, hello again world. S3, hello yet again world. And S4, also hello world. So you can see S1 and S4 seem to contain the same text, exactly the same text, hello world. Yet, when I compare S1 and S4, the answer I'm seeing in the output is false. What's going on over here? I mean, I'm expecting S1 and S2, S1 and S3, I'm expecting those to be not equal because they reference different strings. This one's hello world, S2 is hello again world, and S3 is an empty, a null string. But why is the result of comparing S1 and S4, which seem to be strings containing the same text, why is the result of that also false? Now the answer to that is, again, as you already know it, this comparison over here that we're doing, S1 equal to S4, S1 equal to 3, S1 equal to S2, is not a comparison of the actual string, of the contents of the string, not of the text that they contain. This is just a check to see if reference S1 points to the same string object as reference S2. So, we make a small change. You may have noticed that I created uh, S4 using this new keyword. What if I do this? I create S4 and I point it to hello world. And let me run this comparison again, see what we get. Whoa, S1 equal to S4 is true. It seems like I'm creating a new string, S4, which also contains hello world. But this time around, what this means when S1 is equal to S4, what it means is that S1 and S4 both point to the same strings. Now, let me explain what's happening over here. This is known as internment or intern strings. Sorry. As an example that explains it in the slides, this is what's going on over here. So we have string S1 contains welcome to Java, string S2, which is a different string, also contains welcome to Java, but the second string S2 is created explicitly. It is a new object created using the new keyword. So we know this string S1 is definitely different from string S2. But then when we create string S3, we create it again using using this shorthand notation we've been using. Now, what happens in Java is, in the interest of saving memory, happens is that the JVM, when you do this, it basically looks for any pre-existing string object that contains this text. And look what happens. S1 is created, we have one object. S2 is created, we get a new object because we are creating it using the new keyword. But when S3 is created, there's already a string object containing the text welcome to Java. So what the JVM does is, this new string, this newly declared string S3 reference points to the same string object that already contains welcome to Java. This is exactly what's happening over here. When we create the new string S4 and set it equal to hello world, there's already a string object containing this exact same string, this exact same text. So what happens is S4 is basically a reference to a string object that already exists as S1. And when you do a comparison of S1 and S4, the answer or the result turns out to be true. Let me change it back again just to clarify. String S4, comment out S1, string S4. If I create S4 using the new keyword, I force the JVM to create a new object. Contents string are exactly the same as those of string object S1, yet when we perform the comparison S1 equal to S4, the result is false. Try it out, and I hope you understand the difference between what's going on over here. In this case, we have an intern string. In the other case, we force the creation of a new string object. Okay. Now, strings have string class comes with lots of different useful methods. I don't think I'll be going through all of them. Some of them are actually pretty straightforward and obvious. But we've just seen that we can check whether two string references, two created strings are pointing to the same object in memory. But how do we actually compare one string or the text in one string object to the text in another string object? So for that we have the equals method. And there are actually two variations of it. There's the equals method, and then there's the equals ignore case method. So in ignore case, basically upper and lower case characters are treated as equal. Um, take a quick look. Okay. So system dot out dot print line, and let's sorry, let's compare s1 dot equals, let's compare it with string s2, and let's do the actual thing. So this is this is just a pretty label in orange, and this is the actual call to equals. Okay. Also do ignore, and also do the other one actually. This is one, and then we can make a comparison of the contents. We can compare the contents to hello world. This time all in lowercase. And see how that goes. Okay. So first we compare hello world against hello again world. Should be unequal. And then we compare with S1 with hello world, but hello world is in lowercase letters. This should also be false actually. Let's try that out first. False and false. Okay, let's make a slight change. And let's use the equals ignore case version. Equals ignore case method. Let's ignore the case of the letters. Okay. Let's run it again. And look it up. S1 equals ignore case, hello world, and this time turns out that hello world in uppercase and lowercase is treated as being equal because the capital H and the capital W are treated as equal to the lowercase h and lowercase w. You'll notice I did something slightly strange over here. I did not put I did not use the double quotes uh, in here inside the text, because if I put double quotes inside the text, you can see this ends the string over here. There's a way around that. We can use something called an escape character. I can simply put a slash before the double quotes, and what that will do is the compiler will understand that the character coming after the slash, so this slash has a special function. It's called an escape character. The character following it usually has a special meaning, but that special meaning should not be applied. So this way I can put slash before both double quotes over here. Let me run this again. And now I can put quotes inside a string that I want to store using escape characters. Okay. Uh, Slightly similar to the equals method is the compare to method. What this does is this doesn't return a boolean, a true or false value, but an integer. It returns an integer greater to 0, equal to 0, or less than 0 to indicate whether the string is greater than, equal to, or less than uh, the string in the argument. So again, something we can do. System dot out dot print line. and s1 dot compare to, and let's compare the string s1 to the string s2. They're of very different lengths, as you can see. String s2 contains the extra word again and the comma, and so is so the value will be an integer. Okay, so there you go. Run this. See, s1 is, the string is less than, it's shorter than, it's less than the string s2. I can compare s1 against s4. S1 and S4, as you remember, both contain the same strings. If I do that, the answer is 0. And just for fun, let me switch these two out. Let me compare S2 to S1. Now, S2 is bigger than S1, so the answer should be a positive number. There you go. S2 compared to S1, and the value is a positive number, plus 10. Okay. All right. The compare to method also has a variation that ignores the upper and lower case of letters in the string. So compare to ignore case, similar to the ignore case version of equals ignore case, right? Try out the region matches one. Maybe we're going to do that in class. Let me show you the another two: starts with and ends with, returns true if the string starts with a specified string over here. So this looks for the, the string in the argument at the beginning of the string. This looks for the string you provide in the argument at the end of the string. What do I mean by that? Switch over here. System out, print line, and s1 dot starts with, so string in there is begins with hello, is okay, and I'm just going to copy that actually, and this will return true if s1 starts with the string hello, which it does. S1 contains hello, comma, world. It starts with hello. Let's try that out, and let me also do the other one right here. Other variation is ends with, and let's see, S1 ends with the word world. World exclamation sign. So this is going to check if string S1 starts with the word hello. If it does, the answer is true and should be true. The second one here, we check if string S1 ends with the world exclamation sign, which is also true. So we should get true and true over here. S1 dot starts with hello is true. S1 dot ends with world is true. Let me change that out just to see I'm not wrong. So let's say I remove the exclamation mark, run it again, and as you can see. Oh, sorry, let me also remove it from here because I removed the exclamation mark. Ends with world is false. I forgot the exclamation mark. Moved it. Forget it so much. Okay. So we just did the equals ignore case method and the compare to ignore case method. Some examples of how you can use those. The starts with and ends with methods. So some other methods that you have already been using is the um, another method that you can use. I don't know if you've used it before. Is the length method, which returns a number of characters in a string. Um, Switch over here. So quickly system dot out dot print line, and let's say I want to print out s1 dot length, the number of characters in s1 dot length. There you go. And s1 dot length is 13 characters. And let's see. S2 is a significantly longer string. Let's just do this for all of them. Just 3, S4, S3, S4. You can see S1, S2, S3, S4, and the different lengths that they have. Okay. Okay. Um, Another method is the char at or character at a specific location in a string. Let's check that out quickly. System.out.print line, and we're going to check out s1.char at character at. Let's begin with location 0, and it's going to be, so this should return the first character of string s1. Just for fun, let's check out a few more. Let's say character 3 and character 10. Okay, there you go. So first character of string s1 is capital H. Third character is HELL, double L, right? And then the 10th, also happens to be, change that, let me change that to 9 maybe, just so we see something different. And the character number 9 is an R. This is how the indexing of characters in the string is. Indexing begins at 0. So that's why I'm giving the number 0 as argument when I want the first character. Okay, remember counting in Java and C in most languages begins at 0. Okay, so try this out some more if you like. Another method is the concat method, which is short for concatenate, which basically takes a string and attaches another string at the end of it, creates a new object with the string provided in the argument attached, concatenated to it at the end. Fairly straightforward. System dot out dot print line again, and I'm going to concatenate. So s1 dot concat just going to s1 dot concat s2. See what that looks like. Oh, oh yeah, typo s2. There you go. Hello world, hello again world. And yeah, if you want a space in between, I can include a space and concatenate the space with string s2. There you go. Now it looks nicer. Hello, comma world. Hello again world. All right. So, so if you're wondering, uh, the plus sign that we just used does the same thing as the concat method. So as you can see, this using the plus sign to concatenate strings is actually much more readable than using the concat method. But they both accomplish the same thing. So if you think this is equally good, consider what you would have to do if you had to concatenate a whole bunch of strings, like 5 strings over here, and put them into a new string object as 6. If you do that using the concat method, this is the code you would have to write. As you can see, not very readable, not very intuitive. So stick to the addition sign to keep your code readable. So that's going to be it for today. We'll pick up with a few more string topics in the next lecture. And we'll move on from the string class to some related classes that also deal with text in the Java API after this. So I'll see you all tomorrow.